Say for instance, hey, you forgot what the Boolean operators are in Python. You can just simply prompt ChatGPT, because remember, ChatGPT is also a means to help you learn Python further, right? For self-directed learning. So you can just simply prompt it, what are the Boolean or logical operators supported in Python or just in Python? Okay, and it'll just give you a list of each and explain each one with examples. So the first being the and, x and y, x or y, the not, okay? And then it'll even give you like an example of each. So if you have true and false, A and B, A or B, not A, right? So remember, and or not, they are exactly as they sound, which is what I always say. So and means that both of them have to be true in order to give you a true, or only one of them have to be true, and not is basically takes an opposite relation, right? So if it's not true, it's false. If it's false, if it's not false, it's true. Okay, so let's look at some examples. So say I wanted some assistance here, AI guidance on how to write a Python program to check if a user's input is, and this is just a very basic check, less than, say, less than 10 and greater than 2. Okay, this is just something very basic, and we want it to be simple, and we do want it to use Boolean if possible. So you can see here, it didn't use Booleans, it used comparison operators, which is okay, but I can just simply ask it to use the and. Okay, so it says this program uses the logical and operator to check if the user's input meets, but actually don't necessarily see that it uses and verbatim. So please use the and operator verbatim. And let's go ahead and get that output there. So there it is, the and, as opposed to the former example where it didn't necessarily have an and, it just had the sort of the before and after between the variable, which is, you can do it that way, certainly. But if you wanted to use the and, you're going to check if the user input is greater than 2 and if the user input is less than 10. And then, if it is, then it'll print numbers less than 10 and greater than 2. Otherwise, the number is not within the specified range. So let's take a look at this in Python. So we're going to click on this and just create a new Python file. And this time we're doing Booleans. So we'll just call that Booleans and drop that there. We're on current file, and then we run that. So enter a number 5. So the number is less than 10 and greater than 2. Okay, so if I run this again, let's say I enter 1 this time. The number is not within the specified range. Cool. All right, so that's one example. So say I wanted to write a different kind of program. So write a Python program that will, and we're going to make this one a little bit more meaningful and applicable to, say, the real world. So write a Python program that will check to see if a student is qualified for a scholarship. The requirements are that the student needs to have a GPA of 3.5 or higher, and also they need to be involved in at least 2 voluntary, or you could say extracurricular or voluntary activities. Okay. You can even expand on that and say, or they need to have a GPA of 3.2 and be involved in at least 4 voluntary activities. So now we're just really expanding our Boolean needs here, right? So let me go ahead and enter that and let's see what it gives us. All right, so get the student's information. GPA is equal to flow of the input, enter the student's GPA. Voluntary activities, enter the number of voluntary activities of the student. All right, cool. Great example. So check the scholarship availability, eligibility of the student. So I love this example. It's using comparison operators. It's using Boolean logical operators. This is a great example for us to look at. All right, so you can see here if it's greater than or equal to 3.5 and their voluntary activities is greater than or equal to 2, or the other case, if it's greater than 3.2 or the voluntary activities, or rather, and the voluntary activities are greater than and equal to 4, then they will be qualified for the scholarship. Otherwise, they don't meet the categories for, or the requirements rather, for the scholarship. So let's go ahead and copy this in and play around with it a little bit. So we're going to go ahead and paste it and run. And then the first question is enter the student's GPA. Let's start with the 3.5 or higher. So I'm going to enter a 3.6 here. Enter the number of voluntary activities. Okay, so the number of voluntary activities here, say, would be 2. Okay, which is their minimum. Congratulations, the student is qualified for the scholarship. Now let's play around with this a little bit. So let's rerun this because we're going to get an idea of the Boolean logic here. So say the student is a 3.6 GPA, but they were only involved in 1 voluntary activity. What do you think is going to happen? Now, if you guess that they're not qualified for the scholarship, you're right. And that's because look at the logic of this code. The logic of this code says that they have to have a GPA of 3.5 or greater, and remember the Boolean logic, and have be involved in at least 2 or more voluntary activities. And in this case, yes, they do have a 3.6 GPA, but they're only involved in 1 activity. So that's why they don't qualify. Okay, so hence the application of logical / Boolean operators. So let's run this again. So this time the student's GPA is a 3.3 and the number of activities they were involved in were 5. So they do qualify. Okay. And again, let's look at one more example. So say a 3.4 and they were involved in 2. Nope, they still don't meet it because their GPA is what? Lower, remember. So because it's lower than a 3.5, what happens is the check goes here and the check says, see, okay, yes, it is greater than 3.2, that's true. But then you have this and. Voluntary activities also has to be greater than 4. So the first thing it does is it checks this, okay? And if this is true, then it's done. It's going to qualify you. If it's false, it's going to try again, and it's going to use, because you have an or, right? So it's going to go with the second criteria and see if you meet that one. And that's how or logic works. Either this or that, one or the other has to be true. And if both are false, then you don't qualify. Sorry. Okay. So that's a Boolean example there. Let's look at one more. So this is a fun one. So write a program that simulates a traffic light operation. Something simple like that. I mean, the concept itself seems simple, but actually there's a lot of code involved there. And you can see here it actually used, you know, while loops and time delays. Time delays are essential, and it used a function. So I'm going to modify this and I'm going to ask it to do something else. Rewrite it to make it simpler and use Boolean operators to code this problem. Okay, let's see what it does there. Okay, so it's using the while loop still, and I don't really see that. Okay, so use the Boolean operators verbatim. Okay, for instance, if the traffic light is not green or yellow, then it must be red. So this is sort of like a traffic light check test. Okay, think of it that way. That's what we're trying to do there. So let's see if we can get something like that. There we go. Okay, that's what I'm looking for. Something to kind of check the conditions of the traffic light. Maybe you want to check the quality of the traffic light, for instance, if you're a traffic engineer. But let's say, okay, rewrite this without using functions because we haven't really gotten into functions yet. So we write this without using functions, okay? There we go. So this is just a traffic light simulation, and here are the different Boolean indications. So it's just a simulation. So in this case, it's making the red true. So this is a simulation of a red light. The green is false, the yellow is false. So if the red and not green and not yellow, if all of these are true, then it's going to say red light stop. Okay, because that means if the red is true, in which case the variable here is true, the green is false, and the yellow is false. Okay, and then here's a simulation of the green light, and here's a simulation of the yellow light. Cool. What if we wanted to make those user inputs? That would be fun. So now you can say, can you make it so that the states of the traffic light, and you can even give it, make it more specific, i.e. is red, are user inputs. Let's try that. That way we can actually just get the user's input and ask them what are the states, and then based on that, we'll get some determination, some outputs here. So let's play around with this. This is a pretty fun example here. All right, so we're going to drop this here, and let's run this code based on our prompt. All right, so is the red light on? I'm going to just say false, okay? Is the green light on? And I'm going to say true here, okay? Is the yellow light on? Well, false, okay? Green light, go. There you go. Cool. All right, so I can stop this and say I wanted to rerun it. Is the red light on? I'm going to say false. Yeah, red light is false. Green light is false. Yellow light is, yes, it's true. Yellow light, prepare to stop. Cool. And you know what? It can keep asking you, so it's gonna loop and ask you again and again. So that's one way to do it. You can even enhance this code if you want so that it understands that, well, obviously if the red light is false, and the green light is false, then it doesn't even have to prompt you if the yellow light is true. So you can certainly do that. Sky's the limit. And that's the beauty, again, of AI guidance and coding with ChatGPT as a means to facilitate this type of work.